Have you ever just stopped to think about how you're even watching this right now? I mean, really, how does it work? Well, it all comes down to light. Light lets us see literally everything, from the screen right in front of you to the farthest stars in the galaxy. But how? It turns out the wonderful, kind of complex way we see the world is actually governed by some surprisingly simple rules.
Okay, let's jump right in with a question you can test out yourself. Go on, grab a spoon from your kitchen. Now look into the scoop part. See that? Your reflection is completely upside down. Now flip it over, and hey, you're right side up again, just smaller. So what's the deal here? I promise you, it isn't magic. The answer to our little spoon mystery, and honestly so much more, is all about understanding just two fundamental principles of light. Yep, just two rules. And they explain how light moves, how it changes direction, and how it creates every single image you've ever laid your eyes on. Let's break them down. So, rule number one is all about the bounce. Now, the official term is reflection, but honestly, thinking of it as a bounce is the perfect way to get it. It's the most basic thing light does when it smacks into something it can't go through. Think about throwing a tennis ball against a solid wall. It bounces back, right? Well, light does pretty much the exact same thing. When light rays hit a smooth, polished surface, like a mirror, they don't get soaked up, they bounce right back off. And that reflected light, that's what carries the image straight to your eyes. But here's the thing, this bounce isn't random at all. It follows one very strict, very predictable rule. The angle that light hits a surface is the exact same angle that it bounces off. It's kind of like a perfect bank shot in a game of pool. It happens the same way every single time, no exceptions. So, on a totally flat surface, like the mirror in your bathroom, these perfect little bounces create an image that's a perfect copy of you. It's the same size, it's upright, and it looks like it's as far behind the mirror as you are in front of it. The only weird thing, it's laterally inverted, which is just a fancy way of saying your left hand is its right hand. But what happens when the surface isn't flat? And this, my friends, brings us right back to our spoon. As soon as you curve that mirror, you're changing the angle of the surface at every single point. And when you change the angle of the bounce, you change everything about the image you see. And here it is, the big reveal. The inside of the spoon, that's a concave mirror. It curves inwards, which makes all the light rays bouncing off you converge and cross over at one single point. So if your face is far enough away, those crossed over rays create an image that's completely upside down. But the back of the spoon, that's a convex mirror. It curves outwards, which spreads the light rays out. This always gives you an image that's upright and smaller. And there you have it, mystery solved. We actually use this focusing effect in all sorts of clever ways. That power of concave mirrors is perfect for things like car headlights, where you want to turn a tiny little bulb into a super powerful beam of light. Or, a shaping mirror, where getting right up close gives you a massively magnified view of your face. And the exact opposite is true for your car's side mirror. It's convex for a reason. It gives you a much wider field of view, so you can see way more of the road behind you. The only trade-off is that it makes everything look smaller and farther away, which is exactly why they all have that famous warning stamped on them. Okay, so that's the bounce. Pretty straightforward. But what happens when light can actually pass through an object? Well, that brings us to rule number two, the bend. Its official name is refraction. And just like with the bounce, you've seen this happen 1,000 times before. I mean, this is the classic example, right? You stick a perfectly straight pencil or a straw into a glass of water, and suddenly, it looks like it's broken right at the surface of the water. It's not, of course. The light itself is just playing a trick on your eyes. So this bending trick is called refraction, and it happens anytime light travels from one clear material or medium into another. Think about it. Light travels from the air into the water of the glass, then through the glass itself, and then back out into the air to finally reach your eye. That's a lot of bending. So why does it bend? What's the reason? The core reason is actually incredibly simple. Light changes speed. Light is the fastest thing in the universe when it's in a vacuum. It's almost as fast in the air. But the second it hits something denser, like water or glass, it slows way down. Here's a cool way to picture it. Imagine you're pushing a lawnmower on the pavement, moving along just fine. Then, one of the wheels hits a big patch of thick grass. That wheel instantly slows down, but the other wheel is still on the pavement, still moving fast. So what happens? The whole lawnmower turns, right? Light does the exact same thing. That change in speed forces it to pivot and change its direction. So, just like we figured out how to control the bounce with curved mirrors, we also learned how to master the bend. And we did it with a piece of technology you are probably very familiar with: lenses. They are designed specifically to bend light in very precise, very useful ways. And there are two main types. You've got convex lenses, which are thicker in the middle. They bend parallel light rays inward, so they all meet at a single focal point. Then you've got concave lenses, which are thinner in the middle, and they do the exact opposite. They spread the light rays out, making them diverge. And the power of a convex lens to focus light is no joke. I mean, if you've ever played with a magnifying glass on a sunny day, you know that if you concentrate all those sunbeams onto one tiny spot, you can generate enough heat to literally set a piece of paper on fire. This amazing ability to precisely bend light is the foundation for so much of our technology. It's in the glasses that correct our vision, it's in the cameras that capture our memories, and it's in the telescopes that let us see across the entire universe. All of it comes down to mastering the bend. So let's bring this all back home. These two simple ideas, they aren't just some abstract physics concepts. They are, quite literally, how you perceive reality every single day. And that's really it, the bounce and the bend. Reflection is just light bouncing off a surface, creating the images we see in mirrors and spoons, and refraction is light bending as it passes through something, which is how all lenses work. When you really stop and think about it, the scope of these principles is just staggering. The entire world of optics, from a simple spoon you eat your cereal with to the most advanced telescopes ever built, it all boils down to these two fundamental behaviors of light. So, the next time you catch your reflection in a shop window or see the way the bottom of a swimming pool seems to shimmer and move, you'll know the rules of the game that light is playing. The only question left is, now that you know what to look for, what else are you going to notice?